So digital twin is a game changer for modular data centers. So the word modular here is not by accident, but I will talk more about it later. But obviously, this would apply to all data centers. So, and of course, any other complex facility that you might have. Now, I will first show you an image. So if anyone is following the development of AI closely, and especially maybe even watches NVIDIA's keynotes that their CEO is holding, and this is what I'm trying to do now on a much smaller scale, this is a gigawatt scale data center. So although this is a computer-generated image, these kinds of facilities are popping up, mostly in the US currently. And there are several even larger facilities right now operational in the US, all used to train machine learning models, to train the AI for what's coming next. Now imagine 1 gigawatt. That's 1,000 megawatts. So the peak output of Krško nuclear power plant is 700 megawatts. So it wouldn't cut it. It wouldn't be able to power this. And another feature of these kinds of AI loads is that they are ever-changing. They are changing very fast. So at its peak, this building would draw a gigawatt, but right the next second, it would draw like 100 megawatts, which is nothing compared to a gigawatt, right? So we at Vertiv, I need to click again. Oh, we have sound. You can turn it down a bit. No need for epic battle musics. So we produce the building blocks for these kinds of data centers. And this is where the word modular comes back into play. Because in order to reduce complexity, you can take this kind of equipment and put it on a skid, prefabricated, include all the piping and all the wiring, and reduce your complexity when you're building a data center. So why am I showing this? They told me it's a good thing to actually advertise your employer if you're a part of that company, so I'm doing that. But my point here is that these kinds of facilities are simply too complex for humans to manage. Now imagine a gigawatt scale facility, and imagine some sort of a lack of efficiency of 1%. And translate that into real world, into money, basically, and at the end of the day. Each kind of inefficiency can multiply, it compounds and brings a host of financial issues. Now, obviously, we are already using a lot of complex software. So most of you are familiar with Revit, with Six Sigma, with, I don't know, Inventor, and all these kinds of softwares that we're already using. And a lot of these softwares already enable us to reduce complexity and to communicate better. We have cloud collaboration, and we have design reviews in virtual reality. But all of that is kind of fragmented. So you have your own engineering team that is quite capable, and then a customer has an engineering team. Yes, they meet all the time, and they waste a lot of resources talking, but all of this is really fragmented, because there is no single unifying layer that would facilitate this communication. And of course, down the line, this increases risk. So once the project is underway, any kind of problem compounds again, like in the gigawatt scale data center. All inefficiencies, they come together, they produce damage in terms of cost overruns and the projects being delayed. So we need to make design decisions with the full visibility of the full life cycle. So when we talk about the digital twin, so everyone kind of focuses on the middle, and that is like the final layer that you are able to interact with, that you see. But having a functional digital twin, let's first define it, right? Because I'm using a lot of words, but we didn't define the digital twin. So it's a digital replica of something that exists in the real world, but it needs to be connected. And the best way for the connection is to be in both directions. So you get some data out of the real facility, and you feed it back into the real facility. So at Vertiv, we have a lot of this infrastructure already in place, because you can't just go wake up one day and say, I'm building a digital twin for something, because that digital twin needs data. At Vertiv, we have the monitoring software, and we have the IoT sensors that feed the facility's data into the digital twin. We also design everything in BIM. Some of our guys from the BIM team are here, and you can talk to them about our design process if you like. It's very advanced. So once we design everything in 3D, we already have the facility in 3D. That's basically like the ground layer that needs to be done in order to have any semblance of a digital twin. We have a lot of software development in-house because any kind of more complex app for digital twin will need additional functionalities that are not provided out of the box. And some of the companies that Vertiv recently acquired is going into AI-driven automations. So, for example, predictive maintenance of the data center. We also have a lot of strong partnerships with NVIDIA, of course, with Intel, and with lots of data center operators. So, once we have all that, we can start thinking about actually putting it all together into a digital twin. And this is where NVIDIA's Omniverse platform comes into play. So if Digitech continues growing, there will be a guy from NVIDIA doing this presentation next year. But right now you have me, so bear with me, please. So finally, a sort of like this final polish, this final layer that combines it all together appeared in the form of NVIDIA's Omniverse. And that enables us real-time photorealistic 3D models and a unified environment for multidisciplinary collaboration. Down the line, it will also enable us to do scenario-based simulations and to introduce AI-driven optimizations or the predictive maintenance that I talked about. We have some more of the same here, but let's dive into something that is, now, this is ancient footage, so we're talking months here, so months, because with the pace that the AI is, I mean, of course, AI being the driving factor behind it, but the pace with which technology advances, so months are already like ancient history. So this is a demo that was made by me and my team. So we've gone far beyond this, because this shows really some basic functionalities of what the NVIDIA Omniverse ecosystem can enable us. And everything else is up to us to actually feed the data into and to make it better. So here, this is made on a basis of a design that we call the One Core. So this is a 12 megawatt, so a teeny tiny data center in AI terms, data center reference design for AI workloads. We are showing it here. So this was introduced directly from Revit. And each of these elements, all of the metadata from Revit came through. So our next step here that you're able to see at some point was to introduce user interface, because the interface that you see here, that is NVIDIA Omniverse. This is what NVIDIA provides, but it enables you to build your own app on top of it and to extend the interface and to extend the functionalities. So in this little ancient demo, we basically have the 3D model from Revit. We have the CFD data inside, which is here shown as 2D planes, but can also be shown volumetrically, where you can actually walk through the CFD analysis and interact with the layers. And the very next step that we've done, which is not shown here, is actually introduce the monitoring data from the sensors of the site into it. But like I said, the digital twin should be a digital replica of the real-life facility. And for this particular reference design, we do not yet have the real facility. So actually, this is a digital twin in the making, so to speak. But right now, of course, we are working with lots of customers on their own bespoke versions of the digital twin. What I wanted to emphasize here is for you to check out the NVIDIA's Omniverse, because the NVIDIA has put their full force behind it, and it's actually an ecosystem based on open source code, which is very good for the future of the industry. So a universal scene description is the file format that is being used for this, and from this, you are able to build out your own library of simulation-ready assets that can then be combined into proper digital twin. So that is all from me today. Thank you very much.